Hey guys, here we are starting Module 6.2 class notes with examples 1 through 3. Bit of information in terms of the goals and then the big picture of Module 6.2. We have now, as of the start of this module, we have introduced exponential functions, logarithmic functions, and we've talked a bit about working with logarithms and manipulating them using the log properties, and now we're where we were trying to get, which is actually solving equations using exponentials and logarithms. That's been the goal, because actually the goal from here, once we learn how to solve an equation with these functions, we're going to apply them in some applications. So over the next couple modules, modules 7 and 8, we look at lots of application examples, money examples, where we're using exponentials and logarithms to work out some applications, some word problems. But first, here in module 6.2, let's see how we use our knowledge of exponentials and logarithms to solve these equations. First, it's important to understand and just kind of see the big picture of how we solve exponential functions. The one-to-one property, as you read in your textbook in your pre-class work, the one-to-one property of exponential functions basically says if you have an equation, it's a lot of vocabulary, this one-to-one property of exponential functions, but it actually says something quite simple. If you have an equation where the bases are the same on both sides, then the powers must be the same. If they're equal to each other, b to the s power is equal to b to the t power, and the bases are the same, then the powers must be the same. Well, of course the powers must be the same, because they're equal to each other. That's not rocket science, but it's helpful. So let's apply that. Let's apply that up here in our example, say in example 1 here. We have 5 to the 2x equals 5 to the 3x plus 2. We've got powers of 5 on both sides, so the powers must be equal to each other. 2x equals 3x plus 2. And just that quickly, we're down to an equation where we're just going to solve for x. Subtract 3x on both sides, you get negative x equals 2. Move that negative over to the other side, you get x equals negative 2. And we're good. So if you have an exponential equation where both sides of the equation are powers of the same base, then you can effectively cancel those equal bases and just set the powers equal to each other and work out what x is from there. Same thing holds in question number 3. Let's skip over to example 3. 5 to the x equals 5 to the 1/2 power, because a square root is the same thing as a 1/2 power. So if we have 5 to the x equals 5 to the 1/2, then what is x? 1/2. X equals 1/2. And we're golden. There in example 3, we're good to go. In example 2, we've got a little more complicated situation because the two sides of the equation are not powers of the same number, but they can be manipulated to be powers of the same number. Forget about the exponents for a moment and just look at the bases. On the left-hand side, we have a base of 5. On the right-hand side, we have a base of 25. And you say, well, that's not the same base. But actually, it almost is, because 25 is a power of 5. So I could, follow me here, I could simply rewrite 25 as 5 squared. That's all I'm doing in that first step. 25 is the same thing as 5 squared. And the power in doing that is, now look, You have the same base on both sides. Both sides are powers of 5 now. If we clean up the right-hand side of the equation a little bit, 5 squared to the 3x plus 2 power, you can multiply 2 times 3x plus 2, and you've got 5 to the 6x plus 4 power. Now both sides of that equation are powers of 5. Same base. So if they have the same base, then the powers must be equal. And I can say 2x has to be equal to 6x plus 4. And then I can subtract 6x on both sides, and then divide by -4. And we get x equals -1. All 3 of these examples then are examples where either you have the same base on both sides of the equation, or you can manipulate it to get the same base on both sides of the equation. So if you're looking at an exponential equation where both sides of the equation are or can be written as the powers of the same base, then do so. And that one-to-one property of exponential functions that we have listed at the bottom of the screen here says that then you can just set the powers equal to each other and solve for the variable. That's one type of exponential equation. In the next video, we'll look at a different type of exponential equation that takes a little bit different strategy to approach and solve.